This section 2.3 is about a Venn diagram. The very first definition about this section is about universal sets. The universal set is a general set that contains all the elements under the discussion. So we use the rectangle to represent all the elements. And then the subsets inside the universal set are represented by the circles, or sometimes by other shapes, but most likely that we are using the circle. So for example, we have the universal set of the square, triangle, the dollar sign, M and phi. So we have everything is inside here. Universal set has everything inside. But for the set A, it has only the square and the triangle. Set A has only the square and the triangle. And the set of elements in the U that are not in A. So you don't want anything in A, but still in U under the universal set, which is the rest three of them here, dollar sign, M and phi, because they are not inside A, but still inside the big U. Now we have another two definitions. The disjoint sets, that means they don't have anything in common. Two separate circles. So A is on the left side, B is on the right side. They don't have anything overlapping, or they are not connecting. For the proper subset, all the elements of set A are the element of set B. So the small a is inside a bigger B. For the equal set, if A and B are equal, then A is the subset of B, and B is also the subset of A. So there's just one circle, because they are the same thing. Now the set with some common elements. If set A and B have at least one element in common, then the circles representing the sets must overlap, so they have something in common in between. Now for example, use the Venn diagram to determine, okay? Universal set should have everything, A, B, C, D, E, F, G, everything inside the rectangle. But if I ask you for set B only, then you only focus on the circle B, and this has only D and E. But for set part D, the set of elements in A, but not in B. So you want the elements inside the circle A, but exclude the thing that are inside B. So D is the one that is in B, so you don't want to include that. So we have A, B, and C. In A only. The next one, the set of elements in U that are not in B. So B is this guy, D and E. So you want to exclude D and E. So you have A, B, C, F, G. Okay? Don't include D and E because they are inside B. And you don't want anything that is inside B. The set of elements in both A and B. That means the overlapping region, D only. They are inside both A and B, the middle region. Okay, the next topic is the complements of a set. The complements of a set, we have a symbol for A with the prime. Is the set of all elements in the universal set that are not in A. So the priam here means not inside A, but still belong to the universal set. Okay, so for example, the universal set is a big rectangle. Set A is the circle, the white circle. Then the complement of A is the rest that are outside of the set A, but still inside the rectangle universal set. So A prime is outside. Okay, for example, we have the universal set 1, 2, 3, 4, 5, 6, 7, 8, all of them here. And set A is the number 1, 3, 4, 7. For A prime, so A prime is the stuff that are outside of A. So you don't want to include A. Outside of A, it's 2, 5, 6, 7, 2, 5, 6, 8, 9. Next one is the intersection of the sets. Okay, the intersection of sets A and B is written as the upside down U A B. Is the set of elements common to both the set A and B. That means they belong to both the set A and B. So the X said that X belong to A and X also belong to B. So for example, the union, this is the union. The union between these two sets, you want to find the numbers that are in both of them. Number 8 here, right? So I pick it down. Number 10 is here and here. The reason I don't pick 7 because 7 is here but not here. So we find the common numbers, the common elements. Now between these two, number 1, we don't have anything here. 3, we don't have anything. 5, we don't have anything. 7 and 9, we don't have anything. 2, 4, 6, 8, I don't see anything here. So the intersection of these two sets are the empty set because we don't have any. It's empty. And then 1, 3, 5, 7, and 9 intersection with the empty set is the empty set because the empty set by itself is already nothing, so you don't have anything in common. So that's the final should be the empty set.